Hello, my name is Julieta Diaz and I am a data scientist at TIBCO. Welcome to this Team Studio enablement video. In this video, I will cover how to use Jupyter notebooks in Team Studio. We are starting from the Word Files tab in a workspace I have previously created, and we will click on the Using Jupyter Notebooks file and then click on the Opening Notebook button to get to the Jupyter notebook you can see here. The notebook looks like every other Jupyter notebook you have ever seen. In the first cell of this notebook, we are importing the Python libraries that we will need, which are Pandas, NumPy, scikit-learn, Keras, TensorFlow, and Matplotlib. In this case, we are going to use the Iris dataset, a popular machine learning dataset most data scientists must be familiar with. The goal of this notebook is to build a simple neural network model to predict the type of species of the iris flower. The following step is to add the dataset to the notebook. If you are importing the dataset, it must be associated with the workspace initially. If you go to the Data tab of your workspace, here I already have the iris dataset associated, but if I want to associate another dataset with my workspace, I have to go to the data source I am at, which is TDB, and then go through the file path. Let's say I want to associate this adults dataset I have here. All I need to do is select the dataset, the CSV file, and click on Associate with a workspace. Let's go back to our Jupyter notebook now. So if you have the dataset associated, then you can go to Data, where you will see 4 different options. In the following video, you will learn how to initialize PySpark for Spark and Hadoop. But in this one, we will use the first 2 options. For small datasets having less than 500k rows, we should use the first option, import dataset into notebook. The direct connection will be for small datasets having less than 1 or 2 million rows. Else Pandas is slow and resource heavy. And for larger datasets, we will use one of the PySpark options. As the iris dataset is small, it contains 150 samples, we will use the first option. We just need to select the CSV that is relevant to us importing it. Then, if we press Import, this new cell is automatically added to the notebook. The data frame with our dataset is called df iris CSV. If you want to use the second option, we just need to follow the same steps. Go to Data, select Read Dataset using direct connection, select Dataset, and click on Import. The result will be this new cell that we have here. Once we imported the data, we have a look at our dataset by printing the first rows of the data frame. As you might know, the iris dataset includes 3 iris species with 50 samples each, and it is composed of 5 columns, 4 columns of measures on the sepal and pearl, and the columns containing the labels, Setosa, Versicolor, and Virginica. Here, I'm just describing the dataset, checking the distribution, some statistics, and the data type of the variables. The target variable species is a test field. It needs to be converted to a numeric representation to be used for deep learning. For this, we use a label encoder model based on the species column and then update the species column with the corresponding encoding. Next, we convert the data frame into a NumPy array, which is the preferred input format for Keras deep learning. We separate the feature and target variables into different variables, namely x and y. X has 4 columns and y has 1. We print the feature variables and the target variable to check. Since the feature variables are numeric and each column may be on a different scale, we need to standardize the scaling. We print the content of these features after the scaling. Here I'm converting the label encoding to one hot encoding vector because we don't want the algorithm to misunderstand the target as having some sort of hierarchy or order in them. As you can see, the shape of the predicted variable is different. We have 3 columns rather than 1. Finally, we are splitting the dataset into train and test sets. We will use 80% per training and 20% per testing in this case. We print the dimensions of these datasets. Note that we are not splitting for validation as Keras has a feature to create a validation dataset from the training set. Here we are creating a neural network with just a few layers. We have 2 hidden layers of 108 nodes with a RailDo activation function and an output layer with a softmax activation to predict the probabilities of each class for the input provided. To compile the model, we use a categorical cross-entropy since this is a multi-class classification model. We also use accuracy as the metric to measure loss. The model summary is printed here. It shows each layer, the shape of the output, and the total number of parameters in the model. Now we have the input data and the model. We can start the training process. We set the hyperparameter for training. We will use a validation split of 20%. This means that 20% of the training data will be used in validation. We set the batch size to 16 and the number of epochs to 10. The verbose parameter allows us to print out details of process during the training. We save the history of our model training in the value history. It is always good to see how the accuracy of the model changes after each epoch. For this, we use history value to plot the accuracy of in-sample predictions against the epochs. Finally, we evaluate the model against the testing dataset, printing out the accuracy. Maybe that's the way that I could be assessing how well the model is doing. And I am creating predictions with the model here. I hope you find this video useful. Thanks for watching.